Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we continue on another chapter 7 about the deadlock. In the previous part, we already learned about the synchronization. We already learned about the thread. We also know about the scheduling algorithm. So next part is about the deadlock. And I believe everyone already know about the deadlock because we already discussed in the previous chapter, but in this chapter we go details on the deadlock. So the content for the chapter 7, we will learn about the system model, the deadlock characterization, the resource allocation graph, okay, how to illustrate the process, the resources, and then safe and unsafe state, which we refer to the deadlock. For the safe state and unsafe state, the possibility state that my deadlock can occur, and then the method for handling deadlock. So overall, these are the content of chapter 7 about the deadlock. So the method for handling deadlock, we have the deadlock prevention, the avoidance detection, and recovery from the deadlock. Okay, this one is based on the more to the mechanism that we can use to handle the deadlock. So part 1, okay, this is the part 1. Later on we have another part 2 and part 3. So objective for the chapter is to develop a description of the deadlock which prevents set of concurrent processes from completing their tasks. So at the end of this chapter, you should be able to understand what is the deadlock. Okay. And then to present a number of different methods for preventing or avoiding the deadlocks in a chapter system. So the different method is referred to the previous slide. Okay, this one. Okay, these are the method of handling the deadlock. So the first part, we go for the introduction on the system model. Okay, the first part of our content is about the system model. The system consists of resources, and in the system we also have the process. So resources type, we have R1, R2 until Rm. Means depends on the resources that we have in our computer system. So the resources can be our CPU cycles, the memory space that we have in our computer system, the input output devices that we have in the computer system. So that are type of resources. And you can recall back what we have learned about the resource management that told us about what are the resources. And each resource type has instances. Okay, it may have one instance and it may have more instances. So in this part, resources known in a symbol of R with the uppercase, the capital letter of R, and instances in the capital letter of W. So each process utilize a resource as follow. Okay, you can recall back what you have learned. Okay, in the operating system, we have the process. Okay, we have the multiprocessors, and all the process will utilize the resource that the computer system has. So each process utilize a resource by using the request, use, or release. So process will make a request to the resources or use the resources, and then it will release the resources. Then the other process can use that resources. So that's the process utilize the resource. So you need to remember about the request, use, and release. In the next part, we go for the deadlock characteristic. Is the characteristic of the deadlock. Okay, there are 4 conditions that the deadlock can occur. Okay, so there are 4 conditions that we can discuss on how the deadlock can happen. So the first part is about the mutual exclusions. only one process at a time can use the resource. Means the resource only allocate for one process at each time. The second situation or scenario, hold and wait. A process holding at least one resource is waiting to acquire additional resources held by the other processes. Okay, the third part is about the no preemptive or no preemption. A resource can be released only voluntarily by the process holding it after that process has completed its task. Means that, okay, if one process use the resources, it's only can release the resource when it already complete the task. So no preemption, no interrupt during the process. When the process use that resource, it must use until it finish. The other process cannot interrupt. And circular wait. Okay, there exists a set of processes, multi-processes. Okay, symbol P with symbol capital letter P is referred to the process. So there exists a set of P's of waiting processes, such as P0 is waiting for a resource that is held by the P1. So P1 hold the value, hold the resource. So P0 waiting for the P1. P1 is waiting for a resource that is held by the P2 until Pn minus 1 is waiting for a resource that is held by the Pn, and Pn is waiting for a resource that is held by the P0. So based on this explanation is about the cycle. So cycle waiting here can arise the deadlock. So deadlock can happen when we have the circular wait in our process. Okay, deadlock can occur via the system call and locking or extra. Okay, you can see the example in the reference book, page 318 for the mutex deadlock. Okay, the example of the mutex deadlock. So we continue on the resource allocation graph on how we illustrate it. Yeah, a set of vertices V in the capital letter and a set of edges E. So these are the symbol. You need to know the definition of the symbol. P is for process, R for the resources, W for the instances, V for the vertices, and E for the edges. So V is partitioned into two types. We have P and R. So P the set consisting of all the processes in the system, and R refer to the set consisting of all resource types in the system. So V we have P and R. Okay. Request H directed H from P to R, from the process to the resource. Okay, request P request resource. Assignment H directed from the R to P. So you need to know about the request H, how the symbol PR and the arrow here. If a process make a request to the resource, and if the resource is belong or directed to the or assigned to the P. Okay, this one process a request for the resource. This one resource is belong or assigned to the process. Okay, in order to illustrate the graph, you should know about the symbol. So for process, we have the circle symbol. Okay, this circle symbol, you can put P here, P symbol. And resources is in R. It's is present by this square. So inside the square is referred to the instances for the resources. Okay. This one is request instance. So means the process request instance of resource Rj. Okay, Pi, the process I request instance of the resource J. So the the arrow here from the P to R means P request resource. Process request resource. Okay, for this point, P, the process is holding an instance of the resource. Okay, when the resource is when the arrow is like this one, from right to the left, from resource to the process, so that means this instance of resource is held by the P. Okay, that are how we draw the resource allocation graph. Okay, you can see here we have 4 resources and we have 3 processes. We have R1, R2, R3, and R4. Okay. So this is the processes. We have process 1. So process 1 to R1. R1 to P2. P2 to R3. R3 to P3. And resource 2 to the process and resource 2 to the P2. So if you look at this graph, so we can say that there is no circular points. So this is okay. The process of allocation okay because there is no circle that the process waiting for the resources and the resource need to release waiting again for another. Okay. So that's mean the resources are enough for the processes. Okay. And then how about this part? Yeah, for this part we have 3 processes and we also have 4 resources. Okay, when you look at this part, okay, R2, P1, P1, R1. So you look back at the slide here. Sorry, this one. Okay, refer to the arrow. From P to R means request. P request R. From R to P assign. Okay, P to R request. So P1 request from R1. R1 is assigned to P2. P2 request R3. R3 assigned to the P3. P3 request R2. R2 assigned to P2 and P1. If you look at this scenario or the graph being illustrated, okay, from this one to this one, this one to this one, and this one to this one, it's a circular width. So this part have the possibility that the deadlock may occur because we have the circular and you can look back at this characteristic. When we have the circular width, then the deadlock can arise. So these are the example of the circular width. Okay, and this point, okay, this one also we can have the circular at here. So R2 assigned to P1, P1 request from the R1. So R1 is used by the process 2 and process 3. Process 3 request to the R2 and R2 is belong to the process 4. So if the graph contain no cycles, so that means no deadlock. Okay, if there is no cycle, no deadlock. If the graph contain a cycle, If only one instance per resource type, then deadlock. Okay, if only one instance mean inside this one, if only one instance, then the deadlock may occur. In this case, we have two resource. Okay, in this part we only have one, so this is a possibility of the deadlock can occur. So if the graph contain a cycle, these are two possible situations. If only one instance per resource type, then the deadlock. If several instances per resource type, we can have the possibility of the deadlock. Means there's a high possibility the deadlock can occur. Okay, the next part is about the safe state and the unsafe state. When a process requests an available resource, so system must decide if immediate allocation leave the system in a safe state. So system is in a safe state if there exists a sequence P1, P2, P3 until Pn of all the processes in the system, such that for each process, the resources that process can still request can be satisfied by the currently available resources, plus resources held by all the process with the J smaller than I. Okay, so I refer to the process. Let's say process is F3. So and the J is referred to the process held the resource, and I is referred to the process that requests the resource. So if J is smaller than the I, so it still can satisfy. So the system can be seen as a safe state. So if Pi resource need are not immediately available, then Pi can wait until all the Pj finish. Pj hold that resource, and Pi is the one who is the process that waiting for the resource. Okay, so if the Pi resource are not immediately available, so Pi can still wait until Pj finish the process, so it can pass the resource to the Pi. When Pj is finished, okay, process that hold the resources, okay, Pi can obtain needed resources, execute, return the allocated resource, and terminate the process. When Pi terminate, Pi plus 1 can obtain its needed resources, and so on. So in this situation, we are in the safe state. Okay, safe state, because we still have enough resources that can be used by the processes that we have. Okay, if a system in a safe state, there is no deadlock. Okay, no deadlocks mean we can run smoothly. Okay, if a system is in unsafe state, so possibility of the deadlock might occur if we are in the unsafe state. So avoidance ensure that a system will never enter an unsafe state. So the developer of operating system must develop the operating system to avoid the deadlock from it can occur. So it means that it need to avoid the unsafe state in their programming part, in their coding, in developing the operating system. So we can have three situations: unsafe state here, and safe state here. So when we have the safe state, then everyone will be happy. If we are in the unsafe state, so that means there is a possibility that the deadlock can occur. So these are the situation or the state we have in the deadlock: unsafe, safe, and deadlock. So method for handling the deadlock. Okay, this mechanism or the method needed in order to handling the deadlock. So to ensure that the system will never enter a deadlock state. Okay, that's why we try to avoid it. So we have two parts. First is prevention and the second part is avoidance. First, we try to prevent. Second part, we try to avoid. So this method allow the system to enter a deadlock state and then recover, ignore the problem and pretend that the deadlock never occurred in the system, and used by most operating system including the Unix. So, and for the part 1, we will continue on the methods, okay, on this method for handling the deadlock in the next part. So overall, in this video, we have learned about the system model. We learned about the characteristic of the deadlock, the resource allocation graph, what are the symbol, what is the P, what is the R, what is the V, what is the W, what is the PI and PG, okay, what is the safe state and unsafe state, and then description or explanation about the method for handling the deadlock. We have to prevent and we also have the deadlock avoidance. So the next part, we go further on the deadlock methods, refer to the deadlock prevention, avoidance, detection, and recovery part. So that's all for this video. Thank you and Assalamualaikum.